We're going to either multiply by pi over 180, and the 180 is in degrees, so you can put a little degree symbol. Or 180 degrees over pi. Now you know which one to use. You can use the acronym if you'd like. Or you know that if it's in degrees, you need the degree symbol to cancel off, right? So you need the 180 in the bottom so the degrees cancel off. If it's radians, you need a degree symbol back, so you put the 180 in the numerator, so you keep the degree symbol, right? If you base it off the degree symbol, it's really easy to know. It's either pi over 180 or 180 over pi, and it's because that's a common ratio. Like on your unit circle, if you look at 180 degrees, it is the same as pi, right? So you don't need to memorize it. You can look on your pi and 180 are the same thing, right? So I'm going to do one conversion for degrees here. I want to get the degree to go away. So I can either multiply by 180 degrees and then get degrees squared, which is strange and weird, so I'm not going to do that. I'm going to make sure that the 180 is on the bottom so that the degree symbols will cancel, and I have the pi on the top. And my degree symbols cancel off, and I'm left with 315 pi over 180. Now what did I tell you if you put the pi in to your calculator, what's going to happen? It's going to give you, it's just going to just stay as a decimal, right? Like it literally can't convert to a fraction because pi is a non-repeating, non-terminating decimal. So when you type that one in, what do you get? It's on your unit circle, you don't even have to type it in. What? 7 pi over 4. You'll get 7 over 4, you add the pi back, right? Nothing crazy. Now this one I want to convert from radians to degrees. Radians to degrees, okay? If I want radians to degrees, I need a degree symbol, yes? So I'm going to multiply by 180 degrees over pi, so I get a degree symbol. I need a degree symbol. The pi's cancel off, and I get negative 7 times 180, or negative 7/3, whatever, times 180, or negative 7 times 180 divided by 3. Either way, you get the same answer. What do you get? And then we have to have a degree symbol. Most people are good with that one if it has the pi. But what most people are not good with is B. It's negative 1.4 rads. True statement? It doesn't have a pi, so the pi's can't cancel off, and then people get all confused. It's just going to get you a decimal answer. That's all that's going to happen. So I'm going to still go negative 1.4 times 180 degrees over pi, so I have the degree symbol because I needed a degree symbol. Now what's negative 1.4 times 180? And then I'm not going to just put it over pi. I'm going to put the pi in. So I'm going to go negative 1.4 times 180 divided by pi. What do I get? Negative 80. Could we get decimals? Yes, then you just have to round to what they tell you to, right? So when it has a pi, the pi's cancel off, you can just multiply numbers. When it doesn't have the pi, you have to multiply the two numbers and divide by pi. Okay, you have to put the pi in. Number 4 is a pendulum 30 centimeters long, swings through an arc of 45 centimeters. So here's my pendulum. It is 30 centimeters long, attached to something, and it swings through 45 centimeters. So this would be if it was swinging, right? Swinging along here, and this is 45 centimeters. This is like a one-off example, yeah?
Sorry, whenever you use pi, you just use the pi button.
Yes. Never use rounded 3.14 because it doesn't actually exist, and someone just wrote this all on my board. And it keeps going from there. There's a person in my class who has that memorized, just so you know. It is not me. I have memorized it 5 decimal places. Pardon? No, I don't have Dawson. I'm sure he's lovely. It was me. Okay. So, I have 3.14159 memorized. Don't be all jealous. That's where I stopped. All right. So you're past it. You're past it. Just keep reading. Someone actually cross-checked that, so I didn't. But anyways, so here we have, through what angle does the pendulum swing? So I know that this one here is a radius, because if you actually imagine this, it would be a full circle. Pretend that that's actually in the center. That's a terrible circle. But nonetheless, this would be the center of your circle. That'd be more of your circle. Ignore the outside. I'm not erasing it. So here's your circle. This doesn't exist. This is going to make it totally not be here. So you can imagine it's not there. You're welcome. It's like now it's a lion. Do you see the lion now? Yeah. Okay. Anyways, ignoring the lion. This here is the center of your circle. And this would be your radius, because radius is half the edge, right? From center to rim is your radius. And then this is your arc length. And they want us to find out the center, what theta is, the angle. Now there's a formula on your formula sheet. This is like its own little lesson by itself. I don't actually know how it fits in here, but it does. So it's this very top formula. All the rest of these formulas all kind of connect together. But this one is like a little standalone at the top. So often people forget it exists. But it's theta equals A over R. Now, A, come on. Oh gosh, there we go. A is the arc length, R is the radius, and they have to be in the same units. So if one's in centimeters, the other one has to be in centimeters. If one's in meters, the other one has to be in meters. So they want the theta, which is the angle in between. My arc length is 45 centimeters. Sometimes what they'll give us is they'll give us the diameter, which is lovely. However, we can't just use the diameter. We'd have to divide it by 2 and use the radius, right? Because the formula has a radius. The radius for this one is 30 centimeters. What happens when I have a centimeter over a centimeter? They cancel off. Now, whenever I'm finding a theta, I am finding an angle, correct? Now, how do I know an angle is in degrees? It has a degree symbol. Crazy, hey? How do I know if an angle is in radians? It has nothing. Or it could have rads or radians, correct? So if this cancels off, like this, I'm left with 45 divided by 30, which is what? 1.5. Now, some people add a degree symbol to it. Where are you getting the degree symbol from? Is it just miraculously showing up?
No.
No. It's not in degrees. It's what?
Nothing.
It has nothing on it, which means it's what? Radians. So if you want to, you can write rads. Now, it says, so often on this part of the test, if it gives you this, it won't ask for it in radians, it'll ask for it in degrees. You will get your answer in radians every single time because the formula gets an answer in radians because it cancels off, correct? This formula only works in radians, and that's what I need you to remember. This has to be in radians, so if they give it to you in degrees, you have to convert it before you can fill it in. And why is it in radians? Because your arc length and radius will be in the same units, their units will cancel off, it won't have a symbol, if it doesn't have a symbol, it's a radian, right? Now if I wanted to convert it to degrees, which it also wants it in degrees, how do I convert radians to degrees? Do I multiply by 180 degrees over pi, or pi over 180 degrees? I need radians, 2 degrees. Yeah. Hi.
Multiply by 180 over 5.
And the reason why is we're multiplying by 180 degrees over pi, and then that's going to leave us a degree symbol on the top. If we have a degree symbol in the denominator, it's like you have something divided by something degrees. Like, that's weird. You need the degree in the numerator if it's a degree. So go 1.5 times 180 divided by pi. And I get 86. Says to the nearest tenth. If it says to the nearest tenth where necessary, I would go 86. If it says to the nearest tenth, you have to round it to the nearest tenth. So what do I have to add? 0.0 and put a degree symbol. If you do not have a degree symbol, you have not found degrees. And you're like, but I did find degrees. Cool. You don't have a degree symbol. It's a radian. Okay? So if you have a number on your page without a degree symbol, it is a radian. But you're like, but I found a degree. Don't care. It's a radian. The degree says it's a degree. So if there was ever anything more important than writing a degree, there is none in this unit. So the next one, the way they could ask it is calculate the arc length. So they want us to find A to the nearest tenth of a meter. So we know 1 decimal place of a sector of a circle with a diameter of 9.2 meters and an angle, so theta, of 150 degrees. We need theta equals A over R, which is our formula that's given to us on our formula sheet. I need A. How do I isolate A? Times by R. So A equals R theta. What do I know about theta in this formula? Has to be in radians. So if you put a degree in there, do you think the answer will be on your diploma with a degree in it? Yep, it's wrong. Yep. Yeah. So if you forget that it has to be in radians, you put a degree, that answer will be on the diploma. It will be wrong, and you will pick it. Okay? So, do I have R? Oops. A equals, what's my R? 4.6, because it's half of it, correct? So it's going to be 4.6 meters. And I'm going to use my units, because if you use your units, you'll catch that you screwed up if you use the degrees. Because if you use 150 degrees, you now have an answer, meter degrees. Is arc length in meter degrees? No. So if you use your proper units on this actual formula, you will catch yourself because you have meter degrees. Is that even a thing? No, I don't know what a meter degree is. All right. So my theta can't be in degrees. It can be in radians because radians have no units, right? No units times meters is meters, which is what I need my arc length to be in. Okay? So my theta needs to be in radians. It's currently in degrees. How do I get it to turn to radians? How do I get the degree symbol to get out of my life? Because I don't want it there. Multiply by pi over 180 degrees so that the degree symbol cancels off. Eventually you will see that you will remind yourself that this is actually on your unit circle. So 150 degrees is 5 pi over 6. And now I can plug that in. I never plug in a rounded decimal. You are only allowed to round in your answer, the very last step. So do not put a rounded decimal of 5 pi over 6 in here. Now I'm going to have meters times nothing. Meters times nothing is meters. Yay, it's arc length. It's supposed to be meters, right? So you should catch yourself if you do the degrees wrong, if you put in the degrees wrong. I get 12 meters. Now it says to the nearest tenth of a meter. Is that to the nearest tenth of a meter? If it says to the nearest tenth of a meter where necessary, then you could just put 12. And honestly, if it says where necessary, that's a huge hint that it's not necessary, but someone's going to get a wrong answer, so I have to give you some sort of rounding rule because the wrong answer is going to give a decimal. If it says to the nearest tenth where necessary, that means the answer doesn't come out to a tenth, but the wrong answer will, and I have to give you a rounding rule or you're going to call me over. That's what that says. If it says where necessary, because it's not necessary. Yeah. I don't have a pencil.
It's really good.
Okay, I don't have pencils because my pencils go get beat and walk off on me. So this needs to be 12.0 meters. I started off with like 60 some pencils at the beginning of the year, and then by half the year I had 0 pencils. The probability is terrible on how well would I keep a pencil if I bought a pencil. It's like 0%. It's also, if I buy expensive calculators, what's the chance it gets stolen? About 100%. If I just keep buying the TI-83s, the cheap ones, stay for life. Those puppies don't get stolen. All right. Okay, this is where your little unit circle spinny thing is going to come into account. So, Coterminal angles are angles with the same terminal arm. Coterminal angles are angles with the same terminal arm. So an example, which you're going to use a little spinny thing in a second here. If I have 30 degrees, I would take my little spinner and I'd put it on 30 degrees. True statement? You take your spinner and do that. So, if I start here, and I spin it clockwise back to that arm. Clockwise back to that arm. What am I adding to it? 360, am I not? You're physically spinning it with your hand that whole way, that's 360. So, what could this also be instead of 30? 30 plus another 360. What is that? 390. That is not 390. 390. Okay, you're still on 30. True statement? I'm annoying myself. I keep saying true statement in this last week. I'm going to stop doing that because I'm annoying my own self. All right. So I got to be annoying you because if I'm annoying me, you're hearing it. All right. So if we're at 30, you're sitting on 30? And we're going to go counterclockwise now. We're going counterclockwise, 360, true statement. Oh my gosh, I did it again. See, I'm going to call myself out on it because it's so annoying. All right. Is that accurately correct? Yes, it is. Just going to put my glasses on. Okay. Okay. I'm going to start I'm going to go to my thesaurus and I'm going to look for true and use look up a whole bunch of different words for it and then I'm going to use my thesaurus.
Legit. Wait, we're confused. Isn't that counterclockwise when you go that way?
Did I say counterclockwise? This way's clockwise.
Yeah, you said counterclockwise.
We'll have to turn back to the notes and replay the tapes. I probably did, but I meant clockwise. Okay, we're going clockwise. Clockwise. I drew clockwise. I just said counter. It's just, I'm not perfect. Not even darn close. Not darn tootin', even close. Just wanted to use darn tootin', I've never got to. All right, so let's start counting. Where is that going to be? Okay, I'm gonna rotate myself to 0. Yeah, das ist gut. And then I'm going to get myself here, which is what in negative language? Negative 180. And then I'm going to go, and I'm going to get myself to here, which is negative 270. And then I'm going to travel another how many? No, not another 30. I'm going to travel another 60. 270 plus another 60 is negative 330. If I told you to rotate negative 330, you would take your little arrowy thing. 270 plus another 60, right? And you'd land on 30. Yes? Okay. These are all coterminals. So what are we really doing? We're taking our original angle and we're either adding 360 to it or we're subtracting 360 from it. So if I gave you 30 and you added 360, you would get a coterminal, which is 390. However, if I took 30 and I subtracted 360 from it, which would make it rotate a whole clockwise version of 360, I would get negative 330. Could I keep going? Could I take negative 330 and subtract another 360 from it? Would that make me land on that same arm? Because you would just rotate with your little arrow another 360, right? So if I went negative 330 and I subtracted another 360, I would get a negative 690, which would also land on that arm. Because how would it go? It would take the little arm, negative 690, it would take the little arm, and I would go clockwise, which I have to do for in your old version. So I would go clockwise, and I would go And then I would go again. Correct? It would be 2 rotations. And I would still land on that 30, would I not? It's just called a different angle. Okay, I want you to rotate with your little arrow. So you should have it out. I want you to rotate negative 270. So which way are we going? We're going clockwise. That's the way a clock goes, right? To go negative, you go clockwise. So I want you to go negative 270 degrees. So if you go negative 270 degrees, what does it say there? What say ye? I just went back in time. Clockwise. I think you guys are struggling with clocks. Friends got it. So if we go, I'm just going to borrow yours. Maybe I stole it. So if we're here, which is 0, which is where we sit, correct? And then we go, paying attention, we go clockwise 270. This is how a clock rolls. That's 90. That's 180. That's negative 270. What is it also on? 90. 90 is coterminal with it. It's the same thing. Do you see how it's on 90? Same thing. And how could I prove that? Well, if I gave you negative 270, and I added 360 to it, which I can either add 360 or subtract 360 and get coterminals, because it's just rotating that thing 360, right? That would get me 90. That would be its coterminal, correct? Okay, I want you to rotate that little arrow negative 120. So you start at 0, every single person, and rotate it negative 120. I want you to find out where the arrow would be at negative 120. So you go to 90, and then how many more? 30 more, right? Would get me to negative 120. So you start at 0. I'm just making this up. Start at 0, and I want you to go negative 120. So we get here negative 90, 30 more, negative 120, which is the same as what? 240. It's the same angle, correct? Now how can I prove that? Well, I can go negative 120 plus 360 equals 240, or I could show it vice versa. I could go 240 subtract 360, and I get negative 120. They all land on the same arm. All of them land on the same arm. Does that make sense? That you can land on the same arm with a different angle? Okay. Now, how do we write general form coterminals? Well, you use the principal angle plus 360 degrees N NEI. And I'll explain what the heck that is in a second. So, the principal angle is the angle that actually falls on your unit circle. So you know how you have answers on your unit circle from 0 to 360? Or 0 to 2 pi? The principal angle are those angles. The ones that land between 0 and 360 or 0 and 2 pi. That's principal angles. So, if I took 30 degrees, is 30 degrees a principal angle? So we're going to go theta equals 30 degrees. 30 degrees is the very smallest principal angle, yes? And I told you if you add 360 to it numerous times, you'll get all the coterminals. And if you subtract 360 from it numerous times, you'll get all the negative coterminal angles. Yeah? Add 360, add 360, subtract 360, subtract 360, right? Well, how do we represent that instead of going add 360, add 360, right? I want general coterminal means every coterminal in the world. I want to state it. Well, how do I do that? I take 360 degrees, 30 degrees, plus 360 degrees, and then plus another 360, plus another 360, plus another 360, minus another 360, minus another 360, minus another 360. Well, how do I represent that? I put an n behind it. Because if I put an n behind it, it's 360 degrees times n. Now I have to give n something. I say n is an element of the integers. So if n is an element of the integers, it can be any integer. Integer starts at 0, 1, 2, 3, 4, 5, or 0, -1, -2, -3, -4, -5, right? Onwards. So let's see why this actually works. This is the general form, but why? Well, these are my examples if I filled it in. 30 plus 360, say I make n be 0, which is an integer. Well, that goes away, and I get the answer 30, correct? What if I take my next positive integer? 30 plus 360 times 1. Well, now I get 390. I get the very first positive one, right? After it. What if I filled in a 2, which is also an integer? Now I've just rotated twice, have I not? So now it's 720 plus 30, which is 750. Still a coterminal. Then I could fill in a 3, a 4, a 5. It would go on. But I can also fill in the negatives because it's integers. So I could fill in -1. Then that would be 30 minus 360, which is -330, which we already found is true. I could fill in -2, -3, -4. It would give me all of them, wouldn't it? So that's why it is 360 degrees N, NEI. It can also be in radians. We'd have to use 30 in radians, which is pi over 6. Plus, what's 3060 in radians? 2 pi. And then the rest all is the same. N, NEI. They can ask for the general form in radians or degrees. And I have a couple questions for you. So 7 wants you to determine one positive and one negative rotational or coterminal angle. So I would just add 360 or subtract 360. We'll do the radians, not today, so I'm not going to give you radian questions. And then we need the arc length ones.